Alrighty, in this lesson we are going to continue our work on function analysis, but this time we're going to use the second derivative and see what that can tell us about a particular function. What we have here is a problem about an epidemic, and the nice thing about living in the times we live in, right, is we're all pretty familiar with how these types of things might go. So here we have this function f of t that models the number of infected people t days after the outbreak, right? The thing I notice about f right away is that it's a pretty ugly looking function. So we could take our derivative of this by hand, but what we're going to do is what we often do with ugly functions is we are going to use our calculator to fill out this table here in a second so we can analyze it. Before we do that, however, there's one thing I notice about this function right away, and I'm going to make a note of it because it might be important later, right? So the thing that I notice is that f is increasing for all t values that we can see. So I'm going to say that's definitely when t is less than or is bigger than 0 and when t is less than 22-ish, right? What that means in our language of the derivative, right, is that f prime of t should always be positive. So it's good to note that here because we're about to fill out some values of f prime of t, and that's a good way to check our work. Now, what I want to do now is describe how it's increasing. So here we're introducing a second derivative. The second derivative can tell us how the graph is increasing or decreasing, right? So the first derivative tells us whether it's increasing or decreasing. The second derivative tells us a little bit more. And what I notice here is at about x equals 12, or t equals 12 rather, the graph starts increasing more slowly, right? So as we see, one person gets infected and it starts to spread quite quickly, right? Until this point at which it starts to level off. So that's the property of this graph that we're interested in here today. So f is increasing for all t, but for t less than 12, f is increasing quickly. And in fact, it's increasing faster and faster the bigger t gets. So I'm going to say it's increasing at an increasing rate. And leave yourself a little bit of space because we're going to elaborate on this later. For t bigger than 12, f is increasing at a decreasing rate. So in other words, in this region, growth is slowing down. So most people have already gotten sick, right? And it's spreading more slowly. Overall, the number of people who are sick is still going up, but not as quickly as it was before. Okay, so that's what we're interested in studying. And what we are asked for here is to fill out a table with values of f prime of t, the derivative, and we know those should always be positive, and with f double prime of t, so the second derivative of f. The way I'm going to fill out this table is I'm going to use my calculator to figure out these values of the derivative, because this is a pretty ugly function. So I've already typed it into y1. I'm going to then type in my derivative operator here into y2. I'm going to type in x here. And then we've used this trick before. I'm going to type y1 here. And then this time for my grapher, I'm going to use x equals x, right? That would be my derivative of whatever I put in for y1 at all values of x, right? So that would be my first derivative. I want also my second derivative. So I'm going to be like math 8 x. And now if I want my second derivative of y1, well, y2 was our first derivative, so I want the derivative of y2. And again, x is my x value here that I typed in. This would be super smart to do this along with me on your calculator so you get a little bit of practice finding these buttons. Make sure your screen looks exactly like mine before you move on. And if I want a table, what I can do is I can hit second and then table. And this gives me a list of values. So notice it gives me all these values of y1, which was f, y2, which was f prime, and if I click over, it does y3 for me as well. So what I'm going to do is I'm going to use those values to fill out this table for f prime and f double prime of t. You can either get those values off your calculator, or I'm going to fill out the table here in a second, so you can copy them down for me as well. Pay attention to the t's, right, so we're not counting by ones here. Okay. So I filled out my values. This was y2 for my table on my calculator. This was y3 for my table on my calculator. First derivative, second derivative. What I notice, right, is there's a sign change right here between 11 and 12. And that lines up with our graph, right? So increasing at an increasing rate means, in this case, f double prime is positive, so greater than 0. And as that growth starts to slow down, we say f double prime we see is now negative less than 0. Okay, so that corresponds now with the second half of my graph. Hopefully you're noticing my color scheming here. And the first half of my graph was where my second derivative was positive. So as we look at our algebraic example down here, we see we have some vocabulary that is new. Concave up is our first interval in our graph. Concave down is when my second derivative is negative. So that is vocabulary that we will need. And then this point in the middle, we call this point where concavity changes an inflection point. This is all vocabulary we'll need to know. And it's also good to think about what these words mean, right? So notice on my red interval here, f prime is increasing, right? So my derivative is getting bigger. And then after 12, it starts to get smaller again. So in my blue interval, f prime is decreasing. My first derivative is decreasing. So that's another way to interpret these, right? Is whether my derivative is increasing or decreasing. And that makes sense because f double prime is just my derivative of f prime. So as we look at my algebraic example, the first thing I'm going to do is I'm going to annotate. So increasing means my f prime, my first derivative, is positive. My slope is positive. Concave up means f double prime is positive. So notice I have to consider two different derivatives here, so it's going to be very important that I keep my work organized. So the first thing I'm going to do is I'm just going to find both of my derivatives. I'm going to be like, okay, f of x is this, f prime of x then is just a power rule, and then f double prime is going to be the derivative of f prime. And then this one's going to be quite a bit of work, so make sure you write pretty small. So I'm going to set my first derivative equal to 0. I'm going to start with my increasing intervals. It'll be like 0 equals 4x to the third plus 24x squared plus 36x. And then I'm going to solve by factoring, and notice I can pull out a 4x here. And then again, I can factor 4x, and then this factors, of course, to x plus 3 squared. And notice I only have one 0 here because this one repeats. So then I can find my zeros here. I'm going to do the same thing now with my second derivative, and here I'm finding concave up, right? So I'm going to be like 0 equals now my second derivative, which is 12x squared plus 48x plus 36. And then I can solve again by factoring here. My 12 factors out, and that of course factors to x plus 3 times x plus 1. My two zeros are going to be the solutions to x plus 3 equals 0 and x plus 1 equals 0, and that gives me x equals -3 and x equals -1. So notice my strategy is still the same as our previous work. Here I'm setting f prime of x equal to 0, and for my increasing intervals I'm finding the zeros of f prime. Okay. Now I'm going to make my sign chart, and here is a trick. It's going to be helpful here to line these up nicely. Right, so I'm going to draw them one over the other, and notice these both contain a -3. So I'm going to write those lined up vertically, and then 0 is going to be to the right over here, and -1 is going to be to the also to the right, but not as to the right, right? And then I'm going to go through and plug in values to test. I'm going to leave that to you because I think we're already pretty good at that. For my second derivative to the left of -3, I get a positive value. In the middle, I get a negative, and here I get a positive again. And for my first derivative, I get negative, negative, and then positive. And again, I'm just testing values in these regions. Now, what I wanted is for both my first derivative and my second derivative to be positive. I'm going to highlight now where my first derivative is positive. that's everywhere to the right of 0 here, right? And notice my second derivative is positive over here. But my answer, and this is where this is hard, is where both conditions are true. So my answer here is only from 0 to infinity, right? And that's because even though my second derivative is positive from -1 to 0, I want both my first and second derivative to be positive here. So that's the utility of lining these up.